Hello everyone, welcome back to Let's Crack JEE English, the channel of Unacademy, and I am Jeetendra Dixit. So before starting, let me check whether I'm live or not and my voice. Yes. All right, so it's perfect. So this is my profile. I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for last 11 years. So in this session, we were doing integration and I'll continue that. And today we'll do the integration of trigonometric functions, indefinite integration of trigonometric functions, all right? But before the beginning, let me tell you about the Unacademy subscription and the platform. So as you know, Unacademy is India's largest online learning platform, and once you get the subscription for IIT-JEE, there are many courses you can prepare, for many exams you can prepare for this platform, Unacademy. I am talking about IIT-JEE, all right? So if you take the subscription for IIT-JEE on Unacademy, then you get access to daily live classes of all the educators who are teaching for JEE, all physics, chemistry, and maths. And you can watch their recorded lectures as well. So if you must miss something, then you can watch them later. Watch the recorded later videos. You can also interact with your educator during the live class. You can ask your doubts through the chat. You can send images also, right? So the platform is very interactive. You can, to get the feel of the platform, you can attend special classes, which is free. All these special classes are free for everyone, all right? So if you have the Unacademy application, Unacademy's learning app, and your account, then you can watch unlimited special classes, all right? I mean, all the special classes. So once you get the subscription, then you get access to all the courses, all right? All the educators you can follow, not only these special classes. Live tests and quizzes will also be accessible to you. I mean, you can access all the live tests and quizzes once you get the subscription of IIT-JEE on Unacademy. And everything is pre-planned. All this is well structured. So you get to know the information of all the upcoming exams in advance, lectures, all right? You get the schedule of all the educators in well advance, all right? Schedule means the topic name, timing, all right? So everything is scheduled. You can see it on the platform, all right? So I hope it is clear. You can download Unacademy's learning app from Play Store. So it is available on Play Store. You can download it from there. And after downloading, you can take the subscription. And subscription you can take for 1 year, 2 year, right? 6 months, 3 months, or 1 month, all right? So you can take subscription for 1 year, 2 years, 6 months, 3 months, or 1 month, all right? These are the subscription charges which are going to change from tomorrow, all right? So this is the last day. If you haven't taken the subscription, then you still left, a few hours left. You can take the subscription now. Otherwise, this price and all these prices are going to change. So this price list is valid today only. You can use my code and you can buy the subscription. Otherwise, from tomorrow, 10th of September, price list is going to be like this. This will be the new price for 1 year, and this will be the price for 2 years. That too after 10% discount. All right. So guys, hurry up. It's still valid today. Okay, and take the subscription of Unacademy. All right. So today we are going to do integration of trigonometric functions. All right, integration of trigonometric functions. So let's continue. Let me tell you about the trigonometric functions. 1 minute, guys. Let me check once. It is trigonometric or irrational, because yeah. All right, so we'll continue trigonometric. Irrational will take tomorrow. All right, in next session we'll take irrational functions. So today is trigonometric. By mistake, I think it is written irrational today. So irrational we'll do in the end, I mean tomorrow, no, after this. Today let's continue integration of trigonometric function. All right. So see, if you have integral of this form, first of all, um, let me write the generalized 1 upon a square cos square theta plus b square sine square theta and plus c. It should not be a square. You can take a only. Otherwise, you'll think about of positive numbers. A and b. All right. So a cos square theta, b sine square theta, or c sine theta cos theta. All right. Something like this, d theta, or integral of 1 upon a plus b cos square theta. All right, d theta, or you have 1 upon a sine square theta plus b. All right, so this is the generalized one, which first one I have written, plus d also you can take if you want to generalize it more, plus d even you can take, plus some constant, or you can see terms are of even degree, even if it is a cos raised to 4 theta plus b sine raised to 4 theta, or even 6 theta. Okay, in all such cases in which all the terms are of even degree terms. All right, even degree, you can see this is fourth degree, second degree, right, second degree, to divide by the highest power of cos. All right, like if you have fourth degree terms, then divide by cos raised to 4. If you have like 2 degree terms, divide by cos square. Like in this, let me give you the example. If you divide by cos square, then what will happen? If you divide by cos square, it will be, in the numerator it will be sec square theta d theta, and in the denominator it will be a plus b tan square theta. All right, plus c sin theta cos theta when divided by cos square will be tan theta, right? And this d will be d upon cos square is d sec square, so d into 1 plus tan square theta. All right, now you know, if you put tan theta is equal to t, if you put tan theta is equal to t, then your sec square theta d theta will become dt, right? And this integration is going to be dt upon this tan square and this tan square you can club, so b plus d into t square plus tan terms of tan, which you have only one term, so c into t, and plus a plus d. All right, now you can see it's a quadratic in t, and we know how to do the quadratic, right? We did it in the previous session. So I hope it is clear. Okay, I hope it is clear how to do this. I'll give you one example. Let's take up one example. We'll complete this example. Integral of 1 upon sine raised to 4 theta plus cos raised to 4 theta. All right, see how to do it. You can see 4 degree terms of sine raised to 4 plus cos raised to 4. So how to do it? We'll divide by cos raised to 4. All right, divide by cos raised to 4. Then what will happen if you divide by cos raised to 4? One minute, guys. Just a minute, guys. Just a minute. Let me just check something. Okay, so it will be sec raised to 4 theta divided by, if you divide by cos raised to 4, it will be tan square theta, tan raised to 4 theta plus 1 d theta. All right, now put tan theta is equal to t. So you can write sec square theta, sec square theta d theta is equal to dt. So it will be, now just split this, write this the product of sec square into sec square. One sec square will go with t theta, so you can write dt, and one sec square you can write 1 plus tan square, so 1 plus t square, all right, divided by, in the denominator it will be 1 plus t raised to 4, all right. Now you know how to do it. We have already done it before. Take t square common, right, from the numerator and t square from the denominator, so it will be 1 plus 1 upon t square divided by, it will be t square plus 1 upon t square dt. Now you can write denominator as a function of t minus 1 upon t, because this is the derivative of t minus 1 upon t, all right. So it will be 1 plus 1 upon t square divided by 1 minus t minus 1 upon t minus 1 upon t, let me write t minus 1 upon t the whole square plus 2, all right. So now you can put t minus 1 upon t is equal to u, or you can directly use it, okay. This is your f, this is your f dash, all right. So you know f dash dt upon f square plus a square is what? That is tan inverse of, so tan inverse 1 upon a, 1 upon a is 1 upon root 2, tan inverse of t minus 1 upon t divided by a is root 2. Now put the value of t and you have got the answer. So I think it is clear how to do it, right? So this was one example. Now you try this. The similar way you can do this also. Sine raised to 6 theta plus cos raised to 6 theta. Slight change. So now you can see there's almost similar question. See how to do it. Try it once. Try it if you can do it. I'll tell you in a minute. So what will you do? How do you start it? Marks versus percentile in JEE, upcoming JEE main. I mean this JEE main which has held. Actually, I've done the analysis of advanced marks versus length, but not of main actually. I'll do it after some time. In general, you are asking Mridul, Apur, sorry. Okay, the one which is held. Okay, I don't have much idea about that. Kaushik Rathore. Hello, Kaushik. Kaushik. Okay, so let me finish this integration. Okay, I'll see the difficulty level. Anyways, you are going to get the, okay, marks versus rank. Okay, you want me to predict the rank. That's slightly difficult because this time there's a change in pattern as well, and marks also reduced to 300. instead of 360. So there might be some change. Okay, so we'll divide by cos raised to 6 divide by cos raised to 6 theta in this, and it will be sec raised to 6 theta in the numerator and divided by tan raised to 6 theta plus 1 d theta. All right. One of your senior is getting 150. That means 50%. If he is getting 50%, then his rank should be within let me within 20,000, which I am comparing with previous year's data. So it might be, see, if the papers are difficult, then only he can get below 15,000. Otherwise, it should be between 15,000 to 20,000. As per my knowledge. So if you put tan theta is equal to t, okay, sorry. Now let's simplify this. Yeah, tan theta is equal to t. So this will be sec raised to 4 theta d theta divided. First of all, write like this. Sec raised to 4 theta into sec square theta d theta divided by 1 plus tan theta raised to 6. Now put tan theta is equal to t. So you'll get sec square theta d theta is equal to dt. And after putting t, it will be, this sec raised to 4 is 1 plus tan square whole square. So 1 plus t square the whole square divided by t raised to 6 plus 1 dt. Okay. Now simplify it. One minute. So if you simplify in denominator, you can apply the formula of a cube plus b cube. So it will be 1 plus t square the whole square, and you can write t square cube, so that is t square plus 1, and it will be t raised to 4 plus 1 minus t square. All right, a cube plus b cube formula. So now you can cancel 1 plus t square in numerator and denominator, and the rest of it, now I take t square common. So if you take t square common, it will be 1 plus 1 upon t square, and in denominator it should be t square plus 1 upon t square minus 1. All right. So we have got the similar form which we were doing in the previous, right? So now you can complete it, right? Now you know how to write t plus 1 upon t square plus 1 upon t square as t minus 1 upon t the whole square, right? So in that way we can complete it. So I'll continue with another form in trigonometric functions. So next form is this. If you have integration of trigonometric function as a sine theta plus b cos theta plus c type, okay, this type of integral. In this you can see it's a linear function of sine and cos. You can also have like b might be 0, a might be 0. So you can have only term of sine theta or only term of cos theta, right? So this is more generalized, right? This is generalized. So a cos theta plus c, like this also. So in such questions, you need to put sine theta is equal to half angle formula in terms of tan. So sine theta is equal to 2 tan theta by 2 upon 1 plus tan square theta by 2. All right. And cos theta is equal to, you need to put 1 minus, this is not a substitution. This is just we are just changing the expression by putting the values of sine theta and cos theta in terms of tan theta by 2. All right. Then after that, we will substitute tan theta by 2 is equal to t. All right. So see what will happen once we substitute this. So tan square theta by 2 upon 1 plus tan square theta by 2. All right. So let's take one example. I'll tell you this through one example. Suppose you have 1 upon sine theta plus 2 cos theta plus 1. All right. Say plus 1 d theta. So how to do it? Now put the values of sine theta, cos theta. So you'll get this in terms of tan theta by 2. So it will be sine theta is now 2 tan theta by 2 2 tan theta by 2 divided by, will postpone 2021 JEE in January. I'm not getting your question. Are you asking that the JEE advanced will be postponed? This upcoming JEE advanced exam? No, it is not going to be postponed. Or if you are asking it, JEE main exam of January will be postponed, that is, I mean, too early to say. 1 plus Cauchy, 1 plus tan square theta by 2. So I put the value of sin theta by 2, sin theta, sorry. Now put the value of cos theta. So that is 1 minus tan square theta by 2 upon 1 plus tan square theta by 2. And what else? And plus 1. Now take the LCM. So if you take the LCM, 1 plus tan square theta by 2, which is actually sec square theta by 2, will come in the numerator. Alright. And in the denominator, it will be 2 tan theta by 2 plus 2 minus 2 tan square theta by 2. And plus, if you take LCM, it will be 1 plus tan square theta by 2, right? So now you know what to do. Just put tan theta by 2 is equal to t. So if you put tan theta by 2 is equal to t, then your sec square theta by 2 into 1 by 2. D theta will become dt, right? So multiply by 1 by 2, divide by 2. So now this integration is going to be 2 times of integral of dt divided by, okay? So I'll leave it here. This is the last step I'm writing. So you know, now it is going to be 1 upon quadratic, and we have done that in the previous session, all right? So you'll get this minus t square, and this 2t, so plus 2t, all right? And plus 3. So now you know, just make it a perfect square and finish it. Yeah, integration is a big topic and very important one also. Which topic are you waiting for now? Okay, let's solve some questions, all right? Let's solve, and now rest of the forms which we have done earlier also. These were 2 important ones, and I'll tell you through the questions. Kaushik is there, you are there, and I think 2 more students are there. Who else is there? How to crack maths question quickly in JEE Main? JEE Main, obviously you need to practice maths questions. Maths questions you can crack easily if you do a lot of practice. That is valid in every subject, because in physics also they ask numerical questions. Very few questions are like if you theoretical types in JEE exam, JEE Main and Advanced. There are some topics of physics which are theoretical, which you can just answer. Sakshi is there, all right. But in mathematics, you'll have to solve it, and your calculation and everything should be perfect. If you want to solve like more than 20 questions out of 25 now. But one thing is clear. I saw all the papers of JEE Main this time and last year and last year. They are now they generally ask questions which are pretty similar to questions which we do in most of the assignments, in most of the books. I mean, questions are not very new, fresh as they ask in JEE Advanced. So if you complete a book, like pick a good book or your institute's material, most of the questions are common in most of the books. If you just finish one book, just do one book, then you will be able to solve all types of questions. And then it would be good for you to practice for JEE Main. A, you are getting A. Let me see. Okay, Kaushik. A seems the correct answer. Yes. Yes, suppose A seems the correct answer. Whenever you have sine raised to m x, this is a form cos raised to n x, okay, and one of m or n is odd. Say n is odd, okay. Say n is odd. If n is odd, if n is odd, then put sin x is equal to t, and if m is odd, then put cos x is equal to t. All right. If both are odd, then put any one of them is equal to t. Especially if suppose m and n both are m and n both are odd and m is greater than n, then you just to you can put any sine or cos is equal to t. But if you want to keep calculation low, then you should put the bigger power. Say sine has the bigger power in this example, then you should put sin x is equal to t. All right, if both are odd and m is greater than n, this will help you to keep the calculation low. So in this question, it is clear that cos has the odd power, right? Sin square x and cos cube x. So that means you need to put sin x is equal to t. Then your cos x dx will be dt, all right? And this will become t square. Let's write this cos cube as cos square x into cos x. So 1 cos x will go with dx. It will become dt. And remaining cos square you can write 1 minus sin square, which is 1 minus t square, all right? After that, distribute it. It will be t square dt minus t raised to 4 dt. And then you can write t cube by 3. Yes, so answer is correct. T raised to 5 by 5 plus c. All right. Apurv, yes, we can do that. Actually, I'm doing the same thing on Unacademy's special classes. So yes, if you guys are there, I mean, if your group is there, then we can start that. I can start. I have a good collection of problems and I'm discussing those problems on advanced platform. And yes, there's a crowd. The crowd is good there. If you have a good crowd here also, then I can start that session here. Let me know the topics also, so we can have one. We can start with one session. All right, and let's see how many participants are there. Then we will continue that with other topics also. So you can let me know the topics, and yes, you can talk to your friends who want to attend this kind of session. Okay, I'll start that. Sure. Okay, try this one. Have you seen my sessions on Unacademy? I mean, special classes on Unacademy's Plus. This is there. Basically, I'm taking the same thing which you are asking me to do it here. I'm taking sessions on this crash course type of. Okay, I'll start. Sure. Let me know which topic do you want, and ask your friends to join. All right, we'll start here. No problem. It will be open to everyone. So let me know the first topic, and I'll schedule the session for that. You want a question discussion session, right? Sure. Also, let me know, talk to your friends and you can tell me in next session also that which topics you guys have done and from where you would like to start. Okay. So I'll start with that topic. But yes, obviously we can do discussions or discussion of good questions of only those topics which you guys have completed, right? Hmm. So this is an integration of form a sin x, although this one is very easy, a sin x plus b cos x plus c divided by p sin x plus q cos x plus r. See what we do in this? We express the numerator a sin x plus b cos x plus c is equal to k1 times of the denominator, which is p sin x plus q cos x plus r, plus k2 times the derivative of denominator, which is p cos x minus q sin x, all right, plus k3. Okay, always express the numerator in terms of this. So this one is pretty simple. In this you need to just express sin x as k1 times of the denominator, which is sin x minus cos x, plus k2 times of the derivative of it. So what is the derivative? Derivative of this is cos x plus sin x. Now compare and find k1, k2. So if you compare the coefficient of sin x, you'll get k1 plus k2 is equal to 1. And if you compare the coefficient of cos x, that is minus k1 plus k2, that will be equal to 0. So you'll get k1 is equal to half and k2 is equal to half, right? So you can write the numerator sin x, you can write as half of sin x minus cos x plus half of sin x plus cos x, right? This is your numerator now, and divided by sin x minus cos x dx. And after dividing, you'll get 1 by 2 integral of 1 dx plus 1 by 2, it is sin x plus cos x divided by sin x minus cos x, all right, dx. So integral of 1 is x, right? And integral, this is nothing but f dash upon f. So you know what is the integral of f dash upon f? Ln of, right? So it is plus 1 by 2 ln of sin x minus cos x. It is A option, all right? So I'm getting A option. A is the correct answer. So this was another form which was supposed to discuss. All right. So we did two more forms through problems. All right. Let's continue. So this I have told you how to do it. You try it. You try it. Practice this particular question. You can finish it quickly. Mm-hmm. All right, you guys are getting B. Let me check. So just put cos x is equal to what we need to do. You can see this is a linear expression of sine and cos in the denominator. So directly put cos x is equal to 1 minus tan square of x by 2 upon 1 plus tan square of x by 2, and then proceed. All right. So if you put this, it will be 1 plus tan square x by 2 in the numerator, which is actually sec square x by 2. And it will be 5 times, so I'm taking LCM also simultaneously. So it will be 5 times of 1 plus tan square x by 2 minus 4 times of 1 minus tan square x by 2, all right, dx. Then you can put tan x by 2 is equal to t. So put tan x by 2 is equal to t, and you'll get sec square of x by 2 dx is equal to will be 1 by 2 also. So 2 multiplied by 2, because 1 by 2 you'll have to divide. Uh, sorry. 1 by 2. So you can multiply this 2 to right hand side. So it will be 2 dt, all right. So 2 dt, so it will be yes 2 dt divided by, this is t square, 5t square plus 4d square is 9t square, then plus 4 minus 5 is plus 1, all right. Okay, so you can take this 9 common, so you can write 2 by 9 outside, or okay, directly apply the formula of tan inverse, no problem at all. Directly apply the formula, write this t as 3t square, 3t the whole square. So it will be integral of dt upon 3t the whole square plus 1. Now apply the formula of tan inverse. So it will be 2 times of 1 upon a is 1, so tan inverse of 3t, all right, and divided by 3 also, because coefficient of t is 3. Now put the value of t, so it will be 2 tan inverse of 3. What was your t? Tan x by 2, right? So tan x by 2 and divided by 3, all right. So what is the answer? So your answer is B. Yes, you guys were getting it right. It is correct. B is the correct answer. Okay, this we have done. So okay, let's solve it. Let's solve this one. Thank you, Kaushik. Are you solving the problem or you're just watching it? Try this problem. Have you done integration? Kaushik, are you in class 12th or 11th? Okay. So probably you must have done this integration. Solve it. It's a very easy problem. Mhm. Okay, so Kaushik is getting B, Sakshi is getting D. Okay, let me check. Divide by cos square, right? If you divide by cos square, it will be numerator and denominator both. So it will be sec square x in the numerator dx divided by it will be 9 tan square, and this will become 4 only because you are dividing by cos square. Now you put tan x is equal to t, so it will be sec square x dx is equal to dt, and then it will be dt upon 9t square, which you can write 3t the whole square plus 2 square. Apply the formula of a square plus x square, a square plus x square. So that is 1 upon a tan inverse of x upon a. So x is your 3t upon a. And because 3 is in the product of t, so you'll have to divide by 3 also. So here, this is your answer. Now put the value of t, so it will be 1 upon 6 tan inverse of 3 t was what, tan x, yes, tan x divided by 2, so plus c, so that will be the answer. Got it? So D is the correct answer, not B. You missed this 6, Kaushik. Got it? Got your mistake? All right, so let's try another problem. Let's do this. It is sine x upon sine 3x, which is, you can write in terms of sine, right? What is the formula of sine 3x? It is 3 sine x minus 4 sine cube x, all right? So this was the first step you needed to do. Now you can cancel sine x, so from numerator and denominator. So now remaining expression is 1 upon 3 minus 4 sine square x, all right, dx. Now you have got a quadratic in sine, so you'll apply that method which I've told you in the beginning. Divide by cos square. in the numerator as well as in the denominator. So divide by cos square. So if you divide by cos square of x, in the numerator it will be sec square of x. In the denominator it will be 3 sec square x minus 4 tan square x, alright, dx. Then you can put tan x is equal to t, tan x is equal to t, and your sec square x dx will be dt. So this will be dt upon 3 into sec square. You can write 1 plus tan square, so it will be 1 plus t square minus 4 t square, alright. So now finally you can write dt upon 3 minus 3 plus 3t square minus 4t square. So 3 minus t square, alright. Now you know which formula you need to apply. 1 upon root a square minus 1 upon a square minus x square. So that is 1 upon 2a log of ln of x plus a upon x minus a, right? So that will be t plus root 3 upon t minus root 3 mod. Now put the value of t. So that is tan x. So finally your answer is 1 upon 2a ln of tan x plus root 3 upon tan x minus root 3 plus c. Okay. Yes. So that is. Now try this one. A very interesting and easy problem. Let's see if you can do it. Concept is same. I mean, you can see even degree terms. The concept is same. You can apply that concept. I will be able to solve it. Okay, so we got one answer, Subhash C. All right. Anyone else? Let me solve it then. Okay, so I'll solve it. Let's see if C is the answer. So it is 2 sine 2x can be written as 2 sine x cos x. So you can see overall degree of this term is 2, right? There is second degree term. If you add the degree of sine and cos, it will be 2. Divided by, in denominator, this is fourth degree term and this is also fourth degree term. So if you have all even degree terms of sine and cos, a few terms of 2 degree and few terms are of 4 degree, then also divide by the highest power of cos. I mean cos to the power of highest degree term. So that is 4, right? So we'll divide by cos raised to 4, all right? And you will be able to convert it into a rational function by putting tan x is equal to t. So let's see what are we getting. If you divide, it will be in the numerator. If you divide by cos raised to 4, one cos will cancel, one cos will go in the denominator of sine, so that will become tan x. One cos x is cancelled, and two cos will be remaining, so that will become cos square will become 1 upon cos square will become sec square. So sec square x. So this will be the numerator after dividing cos raised to 4. Now what will happen to the denominator? It is going to be tan raised to 4x plus 1, right? All right. Now let's see what are we going to do. Can you see whose derivative is this? Can you figure it out? This whole thing is a derivative of one particular function. Think. This 2 tan x into sec square x dx is the derivative of some function. So you can write this tan raised to 4 as tan x the whole square plus 1, all right? Then you get tan square x the whole square. Then you can put tan square is equal to, then you can put tan square x is equal to t, and that will give you 2 tan x into differentiation of tan x is sec square x dx is equal to dt, all right? And you can see this whole thing is going to be dt, so it is now dt divided by 1 plus t square. So now it is pretty straightforward, right? The numerator was the derivative of tan square, exact derivative. No need to multiply and divide anything. So it is tan inverse of t, right? Tan inverse of t plus c. Put the value of t, so that is tan square. So it is tan inverse of tan square, all right, plus c. Okay, so I hope it is clear. So this was the problem, all right. Now we have one more problem. Solve it fast, and this will be our last problem. Okay, so let me do it because this is the last question and we are running out of time. So I'll divide it by cos square. After divide by cos square, numerator and denominator both, all right? So numerator it will be sec square x dx, and in denominator it will become 4 tan square plus 4 tan x, right, plus 5. Simple. Now it's straightforward, so you can put tan x is equal to t in this, tan x is equal to t, and your sec square x dx will become dt, right? And now you can see this integration, you can write integral of dt upon 4t square plus 4t plus 5. It's a quadratic in t, so you can, now I'll have to make it a perfect square. So you can make it a perfect, you can write this as a perfect square of 2t plus 1 the whole square, and 5 we have written 1 plus 4. This will be 4. Okay, so now you can apply the formula of directly tan inverse. So it will be 1 upon 2. This is a square, 2 square, so 1 upon a tan inverse of x upon a. So x is your 2t plus 1 upon a is also 2. And you'll have to divide by 2 again because coefficient of t is 2. So again, divide this whole thing by 2. So your final answer is going to be 1 by 4 of tan inverse of 2 times of, put the value of t. So that will be tan of x plus 1 divided by 2 plus c. So which option is correct? Option B is correct. All right. Option B is the correct option. All right. So I hope it is clear. This was the way to integrate trigonometric functions. We have tried almost all types of functions. A few irrational expressions are remaining, so we will do that tomorrow. All right, we'll cover irrational functions in our next session, which will be tomorrow. All right. So thank you very much for attending this session, and like and subscribe the channel, and also use my code JEET1 if you're getting subscription to Unacademy Plus to get 10% discount. All right. One more thing, the price is changing tomorrow, so you are left with a few hours. All right. So take the subscription if you haven't taken it yet.